Okay, here we have y prime equals cosine of x over sine of y, and we have to find the derivative of y prime. That is, the derivative of y prime is y double prime. So basically, we are finding the y double prime, and this equals here we have to use the quotient rule because it is quotient. So I'm going to use the quotient rule, and this means I put the denominator function as it is, that is sine of y times the derivative of the numerator function, that is the derivative of cosine of x, which is negative sine x, and then I put negative. Now I consider the numerator function. I put cosine of x times the derivative of the denominator function, which is sine y. We have to find its derivative. Derivative of sine y is cosine y, and then we have to use the chain rule to find the derivative of y, which is y prime, and this is all over the square of the denominator function, that is sine y quantity square. So let's simplify this. We have y double prime, and this equals the product of these two is negative sine x. We have negative sine x sine y, and we have cosine x cosine y. The product is cosine x cosine y, and I'm going to replace y prime by as we have it here, that is y prime is cosine x over sine y, and this is all over the sine y quantity square, which I can now write down as sine squared y. So it's basically we have to simplify the numerator. If you look at the numerator, we have two terms. This is the first term, and this is second term, which is sort of fraction. And the denominator is sine y in the second term. And this means we have to multiply this first term and divide by the denominator, that is sine y. So let me do that. So I can now write y double prime, and this equals we have negative sine x sine y. We have to multiply and divide by the common denominator, that is sine y over sine y, and we just keep the second term as it is. We can combine these two products, that is cosine x times cosine x is cosine squared x times cosine y, and this is over sine y, and this should be all over the denominator, which is sine squared y. Now, if you look at the only the numerator, we have a fraction, and the common denominator is sine y. So we can now combine the numerator of the numerator fractions. That is, we can now do this product. That is, sine y times sine y is sine squared y. So we will have sine of x, and then sine squared y, and this is over sine y. Maybe we could just combine this terms and put this as a common denominator, and the second term is negative cosine squared x times cosine y, and the common denominator is sine y. So this basically represents the numerator fraction, but the denominator fraction is sine squared y. Let's simplify this. So we have y double prime, and this equals uh, I just put this numerator fraction, that is sine x times sine squared y minus cosine squared x times cosine y. This is over sine y, and we have this denominator sine squared y, which we can now write down this 1 over sine squared y. Now we can multiply these two denominators. So sine y times the sine squared y is sine cube y. So therefore this will become sine cube y. I can just remove this and then just write down this as a single denominator, that is sine cube y. So this is the final expression for y double prime. That is negative sine x, and this is sine squared y minus cosine squared x. This is cosine squared x, and this is multiplied with cosine y all over sine cube y.